So we're going to start talking about sine and cosine. Now, sine and cosine really is our basis for trig. Everything connects back to sine and cosine. So anything you're going to be doing with trigonometry always connects back to your sine and your cosine. So who remembers sine is what over what? Opposite over hypotenuse. And cosine is your adjacent over hypotenuse. So that's how we would always find it before. So keeping that in mind, if I look at my little unit circle picture I have over here, who remembers why do we call it a unit circle? What's 1? The radius is 1. That's why we call it a unit circle. Good. So whenever we're dealing with our unit circle, our angle is always going to be that angle right in there by the origin. That's always the one we're going to be dealing with and talking about. So given the triangle shown to the right inside of our unit circle, let's find sine of the angle, sine theta. So as we set up above, sine was the opposite side over the hypotenuse. So if I look at my angle, what side is opposite of theta? Y. And our hypotenuse is 1, which would just be y. Y over 1 is 1. So sine theta is just that value y. So off of that unit circle that we dealt with last class, when you get those coordinate points, that y value from your point is your sine value of that angle. So if I were to look back here, if I'm looking at my 30-degree angle right here, 1/2 is my sine value of 30. The sine of 30 is 1/2. I get that from that part. Let's take a look at cosine. Cosine, as we said, is the adjacent side over the hypotenuse. So our adjacent side to our theta is x. Our hypotenuse is still a 1. So that makes cosine the x value. So cosine theta equals x. So again, going back to my 30-degree angle, my x value from that was radical 3 over 2, so that means the cosine of 30 is radical 3 over 2. Every x value is cosine, y is sine. So we thus define the sine and cosine functions by using the coordinates on the circle. They are the first functions that are geometrically defined as they are based on the geometry of a circle. So we got to memorize this. Sine, y coordinate, cosine is your x coordinate. So using your unit circle, let's figure out these values. So sine of 30. So if you go to your 30 degrees on your unit circle, look at the y value. What is the y value? So sine of 30 is 1/2. So now let's go to 240 on your unit circle. Negative radical 3 over 2. So the sine of 240 is negative radical 3 over 2. Sine is y. So next one, cosine. So we're switching it up. We want to look at the x now. Cosine of 90 is 0. Cosine of 180, negative 1. So look at our next row, sine of 90. So we're going back to the y coordinate, sine of 90, 1. Sine of 135. Cosine of 150. And cosine of 0. All right, let's keep going. So the terminal ray of an angle, referred to as alpha in here, is drawn in standard position and passes through the point negative 6 or negative 0.6, 0.8, and it lies on the unit circle. So which of the following gives the value for sine? So again, sine is which one, x or y? Y. So our y value here is 0.8, so that means our sine value is 0.8.
Is the 30 degrees moment closest to x?
Yes. So it's important to be able to determine the sign, positive or negative, of each of the two basic trig functions for an angle whose terminal ray is any given quadrant. So the next example is going to illustrate this. So for each quadrant below, determine if sine and cosine of an angle whose terminal ray falls in that quadrant is positive or negative. So the first quadrant, are both our sine and cosine positive? Yes, because both of our parts of our coordinates are positive. So in quadrant 1, both positive. How about for quadrant 2? Sine's positive, cosine's negative. Cosine is your x. Quadrant 3, both negative. And then quadrant 4, sine's negative, cosine is positive. So you guys just have to keep that in mind. So what can end up happening with your unit circle? And let me do a quick little picture of my unit circle here. So we'll say here's my 30. So that's radical 3 over 2, comma 1/2. So all my signs in quadrant 1 are positive. Over here in quadrant 2, only sine is positive. So if I can remember that, I only have to draw those coordinates in my first quadrant and just remember, okay, in quadrant 2, I'm going to make sine positive and cosine negative. If it's in quadrant 3, they're both going to be negative. If it's in quadrant 4, they're both, or sine's negative and cosine's positive. So you don't have to draw the whole unit circle. You can just draw the first reference angles and then keep in mind which one's positive and when. If that doesn't help, you can still keep drawing the whole full unit circle. It doesn't matter. We'll get in some more problems that deal with that stuff, though, so we can practice it. So going back to our equation of our circle, our unit circle's equation is x squared plus y squared equals 1. So now that we know what x and y stand for, we can change it into our Pythagorean identity of cosine squared plus sine squared equals 1. Since x is cosine, y is sine, cosine squared plus sine squared equals 1, and that's our Pythagorean identity. All right. So an angle alpha has a terminal ray that falls in the second quadrant. If it is known that sine alpha is 3/5, determine the value of cosine alpha. So you have to remember, it falls in the second quadrant. So is cosine positive or negative in the second quadrant? Cosine is negative in quadrant 2. So your cosine value in the end's got to be a negative value. So using our Pythagorean identity, sine squared plus cosine squared equals 1. We'll plug in our value for sine, so we got to do 3/5 squared plus cosine squared equals 1. So what is 3/5 squared? Three-fifths squared. 9/25. Yep. So now we should take our 9/25 and subtract it over. Which equals 16/25.
Oh my god, that was.
So we take the square root of both sides, and instead of having cosine squared, we now just have cosine. And what's the square root of 16? Square root of 25. And since it's in the second quadrant, we want the negative version. Because remember, when you take the square, you got positive and negative. We want the negative because we're in second quadrant. So cosine theta equals negative 4/5.
Boom, boom. Boom.
All right, next one, an angle theta has a terminal ray that falls in the first quadrant, and cosine is 1/3. Determine the value of sine theta in simplest radical form. Since we are in quadrant 1, that means we're going to want to keep the positive value after we take the square root, which we're inevitably going to have to take. So again, using our same formula, sine squared plus cosine squared equals 1. Why?
Is it just there? I asked that earlier.
All right, let's keep going. So we're going to plug in 1/3 for our cosine and square that. Let it go, Casey. What's 1/3 squared? Johnson. So yep, we subtract that over, we get 8/9. So now what do we do? Square root. So radical 8 over 3. Can we simplify radical 8?
Yeah.
What's the perfect square that goes into radical 8? 4, and the square root of 4 is? 2. So we get 2 radical 2 over 3. That is our value of sine.
That was subtracted. I'm sorry.
Okay, so we're still going to just do a little bit more with your sine and your cosine. So who remembers sine is which coordinate? Y. And your cosine is your x coordinate. The next page. So let's look at question 2. We got function f of x equals 6 sine of x. Which of the following is the value of f of 60? So we're just going to plug 60 in for our x. So 6 times the sine of 60. So using your unit circle, what is the sine of 60?
1/2.
It's radical 3 over 2.
Radical 3 over 2. So then we got to do that times the 6. So this 2 makes that 6 turn into a 3. Oh yeah, 3 radical 3. Let's choice 2. So 3, we got 4 cosine alpha minus 2 sine alpha, and then we want to plug in 330.
Oh, so the calculator doesn't give the right answer.
Correct. If you're in the right mode anyway.
What mode do you have to put in?
Yep, so we're plugging in 330. So you looking at your unit circle, cosine again is x, so what is the x coordinate of the 330 degree angle?
It is. Yeah.
Radical 3 over 2 will make it 1/2.
So then your y coordinate, which is your sine of 330, would be negative 1/2. So again, this 2 makes this 4 turn into a 2, so we have 2 radical 3. And then negative 2 times negative 1/2. Because you would divide, because this would be up top. 4 divided by 2 gives me 2. Kind of reducing. Because negative times negative is positive.
This is a negative 2. Let's get it.
All right, example 4, which of the following is not equal to 1? So cosine of 0. Look on your unit circle. Cosine of 0 is 1. Cosine of 360. Sine of 90. 1. Sine is the y coordinate.
So it's gotta be 4.
Sine of 270.
-1.
There it is. That's the one that's not equal to 1. 5. For an angle alpha whose terminal ray lies in the third quadrant, it is known that cosine alpha equals -0.96. Which of the following is the value of sine? So it tells us we are in the third quadrant. So in the third quadrant, is sine positive or negative?
Negative. Positive.
Negative.
What? Oh, third, not fourth. Third, not fourth.
So that means we're either choice 1 or we're choice 2. Those are the only negative ones. So then we're going to use our cosine squared plus sine squared equals 1. So let's use our calculator. -0.96 squared. And then what do we want to do? Yep, subtract the 0.9216 over. What do we get? And then our last step. Square root. And again, we said we wanted the -1. In your calculator, type in the square root of 0.0784. Yep, so -0.28, which is choice 1.
What happened to that?
You got it? So there's a special relationship that exists between an angle and its reference angle. We started touching base with that on your homework for today a little bit. So I would like you to make sure your calculator is in degree mode. Push mode and make sure degree is highlighted. If it's not, go down to degree and hit enter so that it is. Degree mode right now. So in your calculator, type in sine of 110. We're going to go to the nearest hundredth. 0.94.
Hit mode with degree highlight.
So I'll do cosine for 110. So go ahead, type in your calculator sine of 70 to the nearest hundredth. What do we get? 0.94. And cosine of 70? 0.34. So what is the only difference we have? This negative sign. Because what quadrant is 110 in? This is in quadrant 2. In quadrant 2, sine is positive, cosine is negative. In quadrant 1, which is where your reference angle would fall, everything's positive. So the only difference is the fact that you're in quadrant 2, so your cosine ends up being negative. Let's try for the next one. Sine of 235. Sine of 235. I got two different answers here.
Negative 0.82.
Negative 0.82. So then cosine of 235. Negative 0.57. So now let's do the reference angle. So 55, sine of 55. 282 cosine of 55. .57. So again, the only thing that's different is the 235, your values are negative, because remember, this is in quadrant 3, where both sine and cosine are negative. Your reference angle being in quadrant 1 are both positive.
Theta would be R, the bottom there, that equation quadrant 1.
Yes, your reference angles are always acute angles, so they would be in quadrant 1. Let's try this one backwards first. So let's do sine of 78 first. What do we get? .98. And then cosine of 78? 0.21. So now, 282, what quadrant are we in? In the fourth. So in the fourth, our sign should be what? Positive or negative? So we got negative 0.98. All right. So cosine of 282. 0.21, and that's exactly what we should have had. All we had to do is take our reference angle, change it to be negative for your sine value. Cosine value should have stayed exactly the way it was.
So you don't even need a calculator to do this. Well, you do, but like...
No, you don't. Because the most times what we're going to be dealing with are the 30, 45, and 60s. And so they always want exact values, which means they want the radicals and not decimals. So you just got to memorize it. So here, given that cosine of 30 is this and sine of 30 is 1/2, they want us to determine the following values in exact form. So exact form means no decimals. You got to have the fractions there. So, as I mentioned before, the values of your trig functions, it depends on which quadrants you're in. So there's a little chart that we use to help us remember, and so then all you have to know are the 30, 45, and 60s, because then you just use your reference angles after that. So over here are my quadrants. If it's in quadrant 1, all of your trig functions are positive, so we put an A there because that represents all of them. In quadrant 2, only your sine is going to be positive, so we put an S there to represent that only the sine function is positive. Quadrant 3, the one we really haven't dealt with too much, is your trig, or your tangent. Tangent's going to be positive in quadrant 3. And then quadrant 4 is your cosine. A means all of them. All of them are positive. So this represents the ones that are positive in that quadrant. So all are positive in quadrant 1, only sines and positive in quadrant 2, only tangent positive, and only cosine. Now there's a lot of different acronyms that people use to remember these. Some people say all students take calculus, and that works for them.
I'm not doing that.
Somebody else told me all students talk constantly.
That is my true.
It's not really true, because not everybody talks a lot.
Rachel talks a lot.
So the one that my high school teacher always told me, and I will always remember, is all schools torture children. And that's the one I've always gone with.
Oh, yeah.
That, my friends, is true.
So,
All students.
so for these examples here, your reference angle for all of them are 30. So all you have to do is pay attention to which quadrant we are in. So 150 falls in which quadrant? Quadrant 2. So 150, quadrant 2, is cosine positive or negative in quadrant 2? Negative. So 150 is the same as the negative cosine of 30. Which right up here, they told us what cosine of 30 is, so we just have to make it negative radical 3 over 2. Because 30 is the reference angle for 150. So for the next one, B, sine, is it positive or negative in quadrant 2? Positive, because you got the S over there in quadrant 2, meaning sine's the one that's positive there. So sine 150 is the same as the sine of 30 because 30 is the reference angle for 150. So what is the sine of 30? 1/2. So C,
Does that mean both of them are?
cosine of 210. So which quadrant is 210 in? Third. So is cosine positive or negative in the third quadrant? Negative, because the only one that's positive there is tangent. So the reference angle again is 30, so cosine of 210 is the same as the negative cosine of 30. So it would be negative radical 3 over 2. So again, our next one, D, we're still working with 210, so we're still in the third quadrant, and sine is positive or negative? Negative, so it's the same as negative sine of 30. So negative 1/2. E, 330, what quadrant are we in now? Fourth quadrant. What is positive in the fourth quadrant? Cosine. So cosine of 330 is the same as the cosine of 30. So radical 3 over 2. So then sine is what in the fourth quadrant? Negative. So this would be negative sine of 30. So negative 1/2. So you're using that reference angle then to find it. So then for 8, evaluate each of the following trig expressions. If it's given to you in radians, just convert it to degrees. That's the one we're more familiar with. So pi over 2 is what in degrees? 90. So looking on your unit circle, sine of 90. Just one. Pi over 3. 60. So again, looking on your unit circle, what's the sine of 60? Radical 3 over 2. 3 pi over 2. So what is the cosine of 270? 0, because remember cosine is your x value. And then 3 pi over 4. So cosine of 135. Negative radical 2 over 2.